All right. So the problem today is that we got a tide rolling in and out with time. So just so you guys can see, this is what we're talking about. Okay, so you got a dock, and then the tide comes in. Come on, tide coming in. It's moving up. Yeah. I actually have been on a dock very similar to this. This is up. This looks like it's up in Alaska. We were at a place eating a fish boil, and the people are like, "Yeah, don't go over to that little island over there because you could walk over there because it was more of a peninsula because the tide's coming in." We're like, oh, okay. We didn't go over there, but then sure enough, the tide came in, and it wasn't an island anymore. It was gone. It was underwater. How does what? It's the gravity from the moon. It's all about where the moon is, and in relation to the holds the water around the earth, and so low tides and high tides. Okay. So a low tide would obviously be when the water is its lowest. Okay. High tide would be when the water is the deepest. Okay. So the table here, which is also the table, actually yours on your sheet, it's not really a table. It's just more of two columns, okay, on your sheet from yesterday. Shows the tides. Okay. What I would like to do now is I would like to use the graphing calculator to create a scatter plot of that data. Okay. So what we're going to need to do is we're going to need to go into lists and spreadsheets. Okay. So actually, let me restart. Double tap on. So one turns it on, two gets it to this screen. You want a new document. You want a new document, and you don't want to save the old one. Okay. Then you want to go into lists and spreadsheets. Then we're going to go up. We got to label our column. So we're going to go up here, and we want to label that as hot. Yes. Now, I can't put 12 a.m. as time, correct? What should I put? 0 as time. Yep. These ones over here work. So I'm going to put in 0 for 12 a.m. What's my next time? 2. Should I put in 2 for 2? Yeah. Yep. Okay, because we're still in the a.m. What about 4? 4, yep. So these are all a.m., so these can all just be What about 12 p.m.? Can I put in 12 there? Yes. Okay. But what about 2 p.m.? That would be 14. on my thing. So we're military, it's the 24-hour clock, if you will. Okay? So we got that. Then we're going to go over to depth. And put in the corresponding depths. Make sure you hit enter after that last one. Because it's out of that stuff. What do you need, Mrs. Hit? Okay. Thank you. Okay. Everybody with me so far? So now what we're going to do is we're going to create a new page. Control dot. To create a new page. Actually, it's data and statistics. Now, we've got to figure out what we want. Horizontally, what do we want to be our horizontal time? Okay. So we're going to go down here, and we're going to click on time. That's going to break it down by time. Vertically, what do we want? Depth. Agree? Okay. So there is your picture. Now, let me go back to here and get it on there. Okay? So there's our picture. We got it on there. Now, let's make, or what you would need to do is you need to recreate that scatter plot now on your graph. So you want to make a quick graph of that on your paper. Those of you joining in at home, currently they're transferring their scatter plot from their calculator to their piece of paper. So now what I want you to do, now that you got your scatter plot on there, now I want you to make me an equation that will fit those data points. Nope, I want you to make it physically. I don't want regressions, I don't want any of that. Yep, I want you to make the equation. Okay? So what do we need?
Amplitude.
We need the amplitude. How am I going to find the amplitude? Okay, so how do I find the middle? What about high point and low point? Average of the high and the low. Okay, so approximately what do you feel is a good middle? This would be my high point, correct?
Yes.
This would be my low point, yes?
3.1.
3.1? 3.1? No. 4.4 plus 1.8 is 6.2. Divided by 2 is 3.1. Okay? So my middle is 3.1. Okay? Which means my amplitude is how much?
1.
gave me a weight? What's wrong? The average, if you take the average of the high and the low, yes, it is the middle. But amplitude then is the distance from middle to high or middle to low. Yeah. So that's that actual distance. Okay? Because this is D, right? And this is A. Okay? Start. Do we agree that start is at 0? Because because it depends on what we're starting at. Well, first off, it depends on what kind of a curve we're going to find, right? So we got to decide that before we figure out start. What do we want to go for? Sine curve? Right. Right. So we'd have to find a different spot. Okay. Or what's the other option that we could do? We could do a cosine and start at 4 a.m. right?
I like that better.
Okay. So we decided we're going to go cosine, and we're going to start. So our start, that was C. Is at 4 a.m. B value is the period, right? What do you think the period is here? What are we thinking, Reed? 12? Roughly? So if my period is roughly 12 hours, Axel, is it phone time or is it math time? Okay, so then we should put our phone away. So if our period is 12 hours, what is my B value? How do I find it? Pi over 6, because it would be 12 equals 2 pi over B. So then B would be 2 pi over 12, which is pi over 6. Yes? Okay. So what is my equation? Y equals 1.3 cosine pi over 6 minus 4 Agree with that? All right. So that's our equation then that we're going to use that would model this. Then it said, okay, find the depth at 9 a.m. So we're going to plug in 9 for x. So that's going to be 1.3 times the cosine of pi over 6 times 9 minus 4 plus 3.1. 9 minus 4 is 5. 5 times pi over 6 is
5
the cosine at 5 pi over 6 is cosine at 5 pi over 6 is, that's the sine. Negative square root of 3 over 2. Cosine is the x value. So we can figure that out. That one, 1.3 times negative square root of 3 over 2, then plus 3.1. I get 1.97. I believe we were in meters. Yep, in meters. Yep. Does that make sense? It does? Hold on. Hold on. 3. Why does it not make sense?
But now it goes lower than our lowest point. Our lowest point is at 1.0.
Does it make sense?
Yeah.
Yeah. We said no. I wanted to make sure that we had the nose taken care of. Okay? Yeah, makes sense. Because it's in between 2.5 and 1.8. Okay? So it makes sense. It fits our data, our data fits our equation. Okay? So that works. Alright? So you now figure out what the depth is at 3 p.m. I got 4.23 meters. 4.225, so 4.23. Okay. Does that make sense?
Yeah.
Yes? Okay. Because it should be coming up, because if we look at our graph, now we got to go back to our graph. We can't necessarily go to our data because it's past our data. If we look back to our graph, we should be coming back up until about 4 p.m. Correct? Because that would be a 12-hour time frame. So at 4 p.m., we should be back to 4.4. This put us at 3 p.m., puts us at 4.23. Makes sense. Okay? Now, the one question that we didn't get to is the last one. A boat needs at least 3 meters of water to motor at the dock. At what times in the afternoon is it safe to dock? Okay? So that again goes back to your graph. So what you would do is you would look and see here, put a line in here. You would look and see when your graph is above that 3 meter line. Okay? So we'd have to find when it is above 3 meters. Well, we could come pretty close to doing that just by looking at the first half of the graph. Because it's a 12-hour time frame, we can say, well, right about here at 1 is when it's at 3. Which means then that it would be at about 1 o'clock in the afternoon over there. Right? 12 hours. Okay. So from 1 until 7-ish, that boat could get into the dock. Because we're on a 12-hour period. That's what happened. The nice part is that we're on a 12-hour period. Now, in all actuality, tide is not on a 12-hour, because it doesn't always happen. It's more like, I think it's like an 11.5-hour period. But yeah, it's goofy, okay? Because it changes every day.